An exponential function is different than a linear function in that an exponential function is a curve, so it can grow or it can fall from left to right. A line is constant increase or constant decrease, but an exponential function is said to grow exponentially. So the characteristics are, if you have y equals ab to the x, this is a general function. Your a is your y-intercept. In b, whatever is being exponentiated is called the growth factor. So your growth factor has to be between, or has to be at least 0. So if it's between 0 and 1, it's said to decay. And if it's greater than 1, it's said to grow, be exponential growth. So if b equals 1, it ends up just being a constant linear function. So that's why it can't equal 1, and we're not defining it with negative either. So exponential growth, if this is your y-intercept b, it's going up, whereas exponential decay goes down from left to right. Another characteristic of exponential growth and decay is that it has what's called an asymptote, so I'm going to spell it out. asymptote. So an asymptote is when a curve gets very close to crossing a line, but it never does. So it gets very close to crossing, this one gets very close to crossing the x-axis, but it never does. So an asymptote can either be vertical or horizontal, so it needs to be a linear, or it needs to be an equation too. So in this case, the asymptote is going to be y equals 0, because it's not crossing the x-axis. So number 1, graph y equals 4 to the 1/2 x. So let's use what we know about the y-intercept being 4. So I'm going to start there. And then we know it's going to decay because the growth factor is less than 1. So it's going to go sloping down. So what you can do is just make a quick table of values to graph it. So plug in -2, -1, 0, 1, 2 in for x. So if you have -1 or 1/2 to the -2 power, you're actually just flipping it over. So I wrote it over here that it's the same thing as doing 2 squared times 4, so 4 times 4 is 16. And if the growth factor is 1/2, one easy way to fill in my table, since I'm going up by 1, is just to divide by 2, or multiply by 1/2, multiply by 1/2, multiply by 1/2, multiply by 1/2. And you can be better about your sketch, but it looks something like this, and you can scale it if you had graphing paper. Okay, number 2, the population of Pulaski, Wisconsin was 5,400 in 2010 and growing, so it tells us it's exponential growth at 3.2% each year. Write an exponential model for the population. So the exponential model is going to take the form y equals ab to the x. So I'm going to use that the initial population is 5,400, that's like my y-intercept. And now this time you have to really think about, if it's 3.2% growing, the growth factor is not going to be 3.2. It's going to be 1 plus, and then write 3.2 as a percent, so it's going to be 0.032 to the x power. So then what you're going to do is, that's our model. So our model has an x and a y, the y and an x. Use your model to predict the population in 2020. So if it's starting in 2010 and you're talking about 2020, what you're going to do is substitute x equals 10 and solve for y. And make sure when you're rounding to the nearest person. You don't leave it as a decimal. Number 3, find an exponential function that passes through these points. So exponential function is y equals ab to the x. So we have to figure out what our y-intercept is and our growth factor. So what I'm going to do is assign this x and y, and this an x and y. So I'm going to plug both of these points into the equations. So I have 4 equals ab to the second power, and 16 equals ab to the third power. So usually when we have systems of equations, we've been solving by add, subtract, multiply. But in this case, what we're going to do is we're actually going to divide these two equations. So I'm going to take the bottom and divide it by the first. And what this is going to do is when I have b cubed divided by b squared, remember you subtract the exponents. So this is going to be b, and then a divided by a cancels out, and then 16 divided by 4 is 4. So I got my work to do b is 4. Now I have to figure out what a is. So what you could do is you could plug a back into one of these equations. So I'm going to plug it back in here. So 4 equals a times 4 squared. So 4 equals 16a. A is 1/4. So just like you try to find your slope in your y-intercept in a linear function, you want to try to find your initial and your growth factor. So I'm going to write my final equation as y equals a, which is 1/4, times 4 to the x power, because b is 4. So don't combine these. We cannot do 1/4 times 4 because this 4 is connected with an exponent. So don't combine those. Just keep it like that. And then let's see, does this make sense if our point? So if we start at 2, 4, I'm going to draw a tiny little sketch here. 2 4s right here. 3 16s way up here. Yeah, it does. That looks like exponential growth. That makes sense for that. So double check it. Number 4. The Schefflers paid $195,000 for their house when they bought it in 2005. House values have been increasing, so this tells me it's going to be an exponential growth function by 1.6% each year. What is the value of their house in 2014? So again, I'm going to go back to my model. And this time the question doesn't read to write a model. I just have to figure out what the value of the house is. So the initial value is $195,000. Now the growth factor, again, you have to think about, don't just plop in 1.6. The equilibrium is 1, and then you're adding 1.6%. So you're adding, and then write this as a percent. Then you have to think about your exponent as the number of years. So if you're going to 05 to 14, it's the 9th power. So in this case, you put this in your calculator, and you're talking about money, so you want to round to the nearest hundredth because there's 2 decimal spots. Number 5, which function shows exponential growth, decay, and what is the rate? So we want to look at their growth factors. So I'm going to highlight this is a growth factor because this has an exponent, and this has an exponent. So this number is less than 1, so this is called decay. And the growth factor is 0.978. Or you could even say it's going down 2.2%. You could get fancy like that. And then B is greater than 1, so this is growth. And it's 5/3 is the rate. And then this one is growth. and the growth factor is 1.0025. So if you're talking about a percent, it's going up by 0.025%.